All right, confidence intervals unit test. Here we go. This question was a little bit tricky. I had to read it for a little bit until I figured out what was going on. But the idea is in a confidence interval for a proportion, you're working with this formula. Which really just means you need to know how many people you sampled, the critical z-value you want, and the proportion you found in favor of the result you were searching for from your sample. It's used in like kind of three places here. So you only need three things: your sample size, your critical z, and your sample proportion. Okay, now they're asking you to compare how changing the sample size is going to affect this. And the idea is normally in a question like this, you'll probably see that they want to build a z-interval with the same level of confidence. And they haven't said that this time, but if they said same level of confidence, really what you're doing is you're comparing the square root of 50 in the denominator to the square root of 100 in the denominator. Okay, now if you do that, the root of 50 is really just going to be, it's on the bottom, 5 root 2, because you can square root of 25, and there are two 25s that are left over. Or more so, the 25s are brought out, and the group of 2 is left in the root, because you can't just square root a 2. Now, 100 square roots to 10, but really the best way to see that is that's 5 times 2. In other words, you can break out 4 groups, which roots to 2, of 25, which roots to 5. And the thing is, this is not double precisely or half precisely. And that's another way of saying 2 times the size. And the idea is we don't know anything about these margin of errors because they haven't said if the z-interval is going to use the same level of confidence. That's the only thing that guarantees this. So a lot of work to show how you could analyze problems, but you have to, if you're going to compare how the margin of error is going to behave, you have to assume they have the same sample proportion and you're taking the same critical z-value. Alright, now also the idea is they're actually, I guess if you see this, the way to make these equivalent is if this one was multiplied by another square root of 2. So that's what that answer is explaining there. Alright, so now we're doing a proportion confidence interval. Now I have my formula right here, so we're just going to go for it. I need my sample proportion. So that's 20 out of our 50, so that's just 2 out of 5, which is also 0.4. And again, you're going to see that 0.4 three different places in a sense. So we're definitely looking at C or D. And the question is, what's 99 confidence on the z-table? If you want to find that, you actually look at the bottom of the t-table, and there it is, the 2.576. So this is our correct answer. So again, 1 minus 0.4 is 0.6. Uh-oh. Okay. So this question essentially boils down to what t-value should you use. So we're actually still going to be in the same table as last time, but they tell you that n is 6. That means your degrees of freedom is 5, which is that sample size minus 1. So we find 99% confidence. It's the first half. Degrees of freedom 5. So we should be using this value where they overlap. df5 and 99. What is going on? gonna try to reload the page here. Okay, hopefully this goes a little faster now. So, we're trying to do a proportion interval. So let's see if we met all the conditions. Now again, you saw in a past free response analysis that if you are asked to compute an interval, you need to check these yourself. They're not going to explicitly say that in the wording. So did they say the word random? Yes, they did. Is our number, can they be considered independent? And they actually can't, because there's 150 seniors and you sampled 30. That's 20% of the seniors. So you can only sample 10% or less. And also, if we sample 30 and 7 of the 30 would order the vegetarian, well, that's less than 10 successes. So we don't have 10 successes. We do have 10 failures, because if 7 are the vegetarian, then 23 are not, so that's safe. But the only thing this really meant was that it was random. All right. So can we make a t-interval out of these? And the answer is no. The reason is because, first, these shapes do look funky. They don't look approximately normal, but that would have been okay if these used more than 30 data points. So because they are small sample sizes, we need to say, since they're small, do the distributions at least look symmetric? And the long story short is they don't. Why is this still happening? All right, I'm going to try closing my internet and reopening it. Oh, that looks great. Okay, let's see how this goes. Critical z-value for 80% confidence. So again, easy giveaway question. It's almost too easy. 80% confidence is 1.282. Now we're cooking. Okay, now it's time to construct an interval for the mean. So let's do that. So their data is symmetric with a mean of 700 and a standard deviation of 50. Again, notice what they say there. It's because they sampled a sample size of less than 30. So they have to make sure that this condition is met, that it's roughly symmetric. It's what failed in the last question. So anyways, a mean confidence interval is just given by your sample mean plus or minus your critical t-value. And your t-value is going to be, well, we want 95% confidence. We only sampled 14. Now again, we're using t because it was a mean question. So we need degrees of freedom 13 for 95% confidence. 95. Follow that up till we see df13. So plus or minus 2.16. And the standard deviation is calculated by the standard deviation of the sample divided by the root of n, which was 14. Okay, so notice here that they don't just have this whole thing written out. They actually simplified this a little bit. Now again, if this is AP exam day, you can leave it like this. That is technically correct. What about the root of 14? There we go. So 28.86, which rounds to 28.9. Oh my gosh. Okay, and so now we're talking about getting a particular sample size, and we're doing this for a mean question. So in a mean question, again, what controls your margin of error, the margin of error is what goes after the plus minus, so it's here, in this case, your critical t or z-value. When you're looking for a particular margin of error, it's always a z-value. And then again, in this question, the idea is, since it's mean, it's your given standard deviation over the root of n. That's what the margin of error is, the second half of your confidence interval after the plus minus. Now, long story short, if you end up solving for the square root of n, you're going to end up getting that n is equal to this times the standard deviation you found squared. So really it's just everything is multiplied and divided together and then squared. So let's see here. We have 99% confidence. Now again, when you're looking for a sample size, you always use the z-value. So 99% confidence for z is 2.576. 2.576 divided by, they want that margin of error to be no more than 8. Okay, and then that was multiplied by the standard deviation of 30. And then again, because these are all multiplied together, you can actually just square root it all or square it all at the end. It will be okay. And you're always supposed to round up. Always round up. So here we go. All right, technically, if you round it down, what you're doing is you're actually making the interval a little bit wider, or more so. Actually, if you round down, what happens is you end up just kind of making an error. You're saying you're 99% confident, but because you're rounding down, you're actually inadvertently making it a different size than what you said it was supposed to be. Okay, anyways, now this is the same question, find the sample size with an assumed p. If they never tell you what the assumed p is, or sample proportion I should say, then you assume that it's 0.5. Now in this case, your margin of error is still given by this z-value, but now it's being multiplied by, and I'm going to write it like this, the square root of p, and then 1 minus p, which we sometimes write as q, divided by n. Now this same setup, if you solve it for n, you'll end up getting, and you'll see why I wrote the first one like this instead of putting everything in there. You'll get z over me squared, just like before. And this time, instead of standard deviation squared, you get p hat times q hat. Okay, so there we go. 95% level of confidence that's what they want. That z-value is 1.96. This time, since everything's not just being squared, I actually do have to use my parentheses here. So again, 95% is 1.96. They want to be within 2 percentage points. We have to put that in as a decimal. That's 2% as a decimal. Oops. Squared times the assumed 0.9 times the opposite of that, which would be 10% or 0.1. And so 865. And that's it. Sorry this video took a while because of the loading. But one thing I want to say in general is just what a confidence interval really is. A confidence interval is using only sample data to interpret what the true population proportion could be. If you've looked at the FRQs, that is the essence of the idea, is that you're creating a estimate for where the true value could be with a certain degree of confidence. All right, good luck.